So this is the second of 3 lectures about Windows, and we're just going to do the registry. Those other 3 things we'll do next week. You've already done it a bit in the project, but the registry is a really big and amazing thing. The amazing thing about Windows is its fantastic, absolute contempt for logic. If there are like one job to do, Windows will do it 10 ways. Because they don't care at all. They don't seem to know anything about math or logic or care. What they know about is business, especially big business, giant corporations. So they design features to meet the real need of a very complicated business. They do not design like Unix would design a fundamental little function that does one thing. And then you can tie together 4 of those functions to accomplish something else. And because they're mathematicians, they would make elementary functions that can do anything. And Windows doesn't care at all. If they have 10 things that appear to do almost the same thing, each one of them designed for a different business case. That's how they think. So anyway, the registry is originally, back in MS-DOS, you'd have these text files everywhere, like autoexec.bat and win.ini, and config files for each application. And each application would install sort of independently from the operating system and dump config files wherever it wanted to dump them, which is the way Linux still is. Like if you install Apache, you have to go read the Apache docs to find out what they do for configs. If you install something else, it's completely unrelated and different. They decided to tie it all in this one registry object. For some ungodly reason, the registry object is not even one file. It is a strange mess created out of a bunch of Hive files. And so you have 5 main registry hives, which are here. These are the root hives: classes root, current user, local machine users, and current config. And those do not correspond to 5 files on the disk, not even remotely. They correspond to 11 files plus a bunch more on the disk. And 2 of them are not even real. They're virtual ones that are created as a subset of the others. It is very baffling and illogical, and that's the way everything about Windows is. It is designed by large committees of people who are primarily in the business of shooting each other down because of Microsoft's force ranking system. So anyway, the 5 main registry hives that make this are in this system root is C typically, system32 config. You'll find these 5 files with no file extensions: system, security, software, SAM, and default. And those are the main ones that have the registry. I think I should turn off these little lights so I can figure out how. That might make it better. Anyway, all right. And then those hives are shared by the entire machine. So anything you find in those Hive files affects the whole machine. And therefore, you will not know what user did it. That's something like the prefetch folder. Remember we talked about this? The prefetch folder has the 128 last launched apps, but it does not tell you who launched them, because there's one prefetch folder shared by the whole system. However, probably of more value in most cases to a forensic examiner is the user-specific hives that are in the user profile, which is now user's username, and the main one is ntuser.dat. There's another one called userclass.dat, and those are the personalized settings for that one user. So these don't take effect until the user logs in. Before the user logs in, these things take effect and handle things like a login password. After you log in, your user.dat file comes in and changes the registry hives, and those are your personal settings, like your background color and your start menu and things like that. And the things you find in there are tied to that user, so you know who did it. All right, so Windows profiles are these things like C user's username. Windows does not create a profile when you create an account. If you create an account, it just makes an entry in the SAM file, which has the password, so that person can log in. But if they never log in, it never creates a profile, because it never stores anything. The first time you log in, it will make you wait 2 or 3 minutes and play a decorative thing saying we're getting things ready. It's creating your profile. So you will not necessarily know how many people are using your machine by just looking at profiles. But if a person has logged in interactively once on the keyboard, then they have a profile folder. If they've just connected like to a network share over the network and had to authenticate with a hash that gave them permission to enter some folder, that does not create a local profile. It just enters that one folder that they asked to access. All right, so the registry, these things that look like folders are called keys. They have values, and the values have data in them, although not all the data is set. Those are the 5 root keys, and HKey users contains HKey default, and then it has HKey users SID. The SID is the unique identifier for each user on the machine, and it has a different subfolder in HKey users for each SID, and HKey user classes is here. to map to the user that file. So the HKey SID is what points to the users, and once a user has logged in, a key is created called HKey current user that is just a pointer that points into HKey user. So this is what I'm saying. This looks like 5 things, and it is nothing connected to 5 things. Even this HKey current user is just a subset of that. It's pointing to the current user. And the same thing's true of current config. The current config has to do with hardware profiles. Hardware profiles is a really old feature that they made a big deal out of in about Windows 2000. You could have a laptop, and then you could have a docking station you plug it into. So now it has a different monitor and a different keyboard and a different mouse, and those would need different drivers. So you could store hardware profiles where you boot it up in one profile for this set of hardware and another profile for that set of hardware. And that's what they call the config. And the current config is the one you're using now. So the current config is not actually stored in the registry. It's created during boot up. What you have is configs stored, various configs, and you have to hunt around to find the current one. Anyway, that's the game here. So another fun thing is registry has timestamps, but they are very rudimentary. The only thing that it has timestamp is a key, and it only has one timestamp, last write time. So if you go to a registry key like this, internet settings, and you change that proxy enable, it will change the timestamp here. And if you change something else here, it will change the timestamp here. Each one of these values does not have their own timestamp. And if that's not messed up enough, the Windows operating system will sweep through and change timestamps at random, sometimes for no apparent reason, and often when it's putting on updates and stuff, it will just change a whole bunch of timestamps. So there are timestamps, but they're not at all as useful or as meaningful as the timestamps you find on folders and files. And here's an example. This guy's trying to look at the run key. The run key is a really common place you look at early on because it's where malware lives. It's one of the many hundreds of ways to make things automatically launch when the machine starts. So malware sits here. So here's things that launch: VMware Tray, Adobe Reader, and Windows Update launch every time you start the machine. And all of them have exactly the same timestamp. That does not mean they were all created at the same time. The problem is their values. And the run key has one timestamp for all of its contents. So the last thing that was added at that time, and you have no way to know which one was the last one. All right. And what's even more fun, which you mentioned before, which if you have a 64-bit machine, Microsoft is really into backward compatibility. So you can run 32-bit software on a 64-bit machine, which is very convenient, but that means if that 32-bit software attempted to write into the registry, it would be writing to the wrong generation of registry. It would be changing keys inappropriately for a 64-bit system. And it would not only mess itself up, it would mess up other 64-bit programs that might be running. So you have to run it in a sort of virtual machine, and they call that a reflection or redirector. So when 32-bit software runs and tries to write in the registry, there are redirectors. So when it thinks it's writing to HKey local machine software, it's actually writing to HKey local machine software Windows on Windows 6432 node, which is a special folder for the lies it's going to tell 32-bit programs. So when 32-bit programs make an API call to fetch data from the registry, it's intercepted and told a lie. And so they think they found it where they put it. When they try to write to the registry, they put it somewhere else, but don't tell the program, just like a virtual machine. Right? Your virtual machine thinks it's talking to the disk, but it's really talking to a little file somewhere. It's a very simple thing, not as powerful as a virtual machine, but it does have the effect that you can run 32-bit software on. But this means you have to look in both places to find everything, and it means if you run a 32-bit forensic tool, you are not going to see the whole registry. You're going to see the illusory registry that 32-bit programs see. Yeah?
You just answered my question. It has to look in 2 different places. So is there a hierarchy? It look here first and then here second?
It detects whether your program is 32 or 64, and then it tells what they tell it, the truth or a lie. The 64-bit programs always see the truth, I think. Although, yeah, because a 64-bit forensic program can look in these WoW folders. Yeah, the 64-bit program sees the truth. So it's like, that's the real machine, and 32 is like a virtual machine. But it's a much less separated from the host than a virtual machine. And by the way, the same thing is true of Docker. This is a big thing that came out, the cow vulnerability. From Clear on Write or something that comes into cow. There's a vulnerability in Linux where some process has a temporary flaw and you can exploit it. And this means Docker containers can get out of the container and take over the root. Because Docker containers are like this kind of virtualization. They're not really a whole virtual machine. They just look like a virtual machine to that one app, but it's really not very separated from the host. Virtual machines are considered much more secure than Docker containers. But Docker containers are much smaller and faster. if you have a server that can run 10 virtual machines, it can probably run 100 Docker containers. But that's because they are not really that separated from the host. Anyway, so here's some registry keys in 4 categories. There's a bunch of these, and what you're going to find is they all do the same thing. And this is just the madness of Windows. They want to customize the machine so it remembers what you've been doing, so it can rearrange windows and menus to look pretty. And they do it in about 14 randomly different ways, and they all mean it's keeping track of everything you do. And all not for any reason of intentionally auditing you, but just to customize the desktop to make it more convenient to use. And you can tell every little team at Windows just added more features with no real logical organization here. So here's the system configuration ones. Here's some important ones your book mentions. You can find out things here like the computer name, the service pack, the time zone, and stuff like that. Now, time zone is pretty important if you want to correct time. The most important one I like here, put the arrow on, is USB store. This was in the project. This is really important for forensic examiners if you're on criminal cases and lawsuits, because you'll first get some evidence from a subpoena or a search warrant, and it's a computer, and the first thing you do is look at USB store, because you have to tell your client to be connecting all these USB devices, write another search warrant or subpoena to grab those devices, and while that's happening, then I'll dig through the rest of this. So USB store is your first stop if you want to find out what's been going on, because the evidence might not be on this machine, it might be on some of those USB devices. Anyway, all right. That's the USB store. Here's network information, where you can find out the information about the TCP interfaces the network has been connecting to, which might be important if you look at wireless networks and you're worried about physically where people have been going, network shares, and the firewall settings.
Wait, so this keeps history?
What's that?
This keeps history? I'm kind of confused. I thought the registry was a live.
The registry has 2 parts. It has these Hive files that are stored on the disk that remember everything.
Oh, okay.
And then when you boot up, it creates certain things. It probes the hardware, and it makes the hardware key based on what hardware is there now.
Okay.
And then it creates some of the keys as it boots up, and then when you log in, it customizes it again. So by the time you actually see a registry and you've logged in, it is a sum of some static things on the disk and some things from the hardware and some things with your user profile. So it's a mixture of everything. All right.
So
Yeah.
as the USB connections are kept, what about network storage devices? Are they also stored?
No.
No, okay.
Just USB, and the reason is because USB devices need a driver. And it has to know whether it needs to go hunt for a driver, or whether it already has the driver. And this is kind of fun. For a while at home, my internet was out, and so I ran through my cell phone for like a month, and I put in a USB wireless card. And what happened is there was a known defect with that USB wireless card on, I think, Windows Vista, which is what I had, so that every time it booted up, it would forget that it already knew about that and create another interface until you have 300 interfaces and the network slows down. USB is fantastically inefficient. It is very common that you have a USB stick, you plug it in, and it fails to recognize it. You just move it to a different port, it recognizes it. It is amazingly inefficient and also very dangerous, which I think we know. People have heard a long time there's malware you can put on USBs. Now, about a year ago, once someone developed a USB with a little capacitor that will physically destroy your machine when you plug it in. So, if somebody asks you to use a USB port, you should really be cautious. You can really mess up a machine that way. Anyway, here's the security policy, which is your audit settings and such. These things, audit settings and firewall, I think would be important if you have malware or an attacker that's turning off these security features or messing with them. Here's information about all the user SIDs. This is where the profiles live. And more information here about users and groups. So those are some general keys. The most important in that list, I think, being USB store, although in criminal cases, you really have to pay a lot of attention to the timestamp and see if someone has been changing the time on the computer, because that is a common thing attackers do, and you have to worry about it. Then there's the Shim Cache. Okay, this is the application compatibility cache, and this is more of Microsoft's backward compatibility. So suppose you buy Windows 10, and you're trying to run some old game or printer driver or something that was written for something really old, like Windows XP or Windows 2000. Other people like Apple would just tell you to go fly a kite and buy a new machine, but Microsoft will always support you no matter how old the stuff is, because businesses have real business needs, where I'm running this MS-DOS cache register and it's still working and I'm not going to upgrade it. So there are these application compatibility settings. You can make a shortcut to an installer and right-click and go to compatibility, and you can tell your Windows 10 machine to, when I run this program, pretend to be Windows XP with no service packs, pretend to be Windows Vista. It will create these settings in the machine that will lie to that installer, so it will find what it expects to find as if it was running on an earlier version of Windows. That's the compatibility pack. So in order to do, once you make those settings, they have to be stored somewhere, and here's where they're stored. These Shim settings are made for every application that can be installed on a machine, which show what compatibility mode to run the installer in. So this will run for any executable scripts. It'll tell you the script name, when it was last modified, the size, and whether the file was actually used. And there are 1,024 of these things. They're maintained in memory, they're written on the registry every time you shut down, and it includes apps that hasn't executed yet. Even if you haven't yet run it, it has already stored this information in the registry, so it knows what compatibility settings to use when you do run it. So this is sort of a super prefetch folder with more entries in it. All right, and it's stored in a goofy binary format, so you have to find a parsing tool, and shimparser.py will do it. So this shows the results of various things like Windows Credential Editor, that's a fun hacking tool, RAR, and so on. Various executables, and when they were last run, when they were last modified. I'm not sure that you get the time it was last run. You do get the time it was last modified, but I'm not quite sure what that time means. That might mean the time you first put it on the machine, rather than last time you run it. And whenever you get to something like that, you really have to do experiments. Like in a virtual machine, if you see the time and it matters, you're going to have to put something on there, look at it, run it and look at it, take it off, look at it, try to figure out what that time means. Research is often what's necessary. All right. And if you read stuff in blogs and stuff, you can't necessarily trust it. Really testing it yourself on a system as close as possible to the real evidence system is the only way to have any good confidence about what these artifacts mean. And this is why it's kind of crazy. This is just like other forensic examiners are looking at footprints and dust that fell out of off somebody's shoes. Nobody intended to make these records for you. These records were for some other purpose, for the Windows to operate better. And so they didn't document how they work, and they didn't make any promises about how they work. So you have to do research and understand when it happens, and then determine what you can decide from it. You know, that's a general property of forensics. You're looking at something that is not an intentional record, so you have to be careful. All right. So, which Hive file has many instances on a single computer? Put that 30. All right. And it's ntuser.dat. Read a popular answer, because the point is these have one for the whole machine, but every user profile has one of these. So there are many of them. All right.
The rest are system ones, right?
The rest are the system ones. So there's one for the whole system. There's just one SAM, which is the list of passwords, and that's it. But each user has their own ntuser.dat. And even if you only have one account, there'll be another one for default, which is the template used to make more accounts in case you make them later. All right. Which one of these is not included in a captured registry? I'll quit at 30. We're till 40, I guess. I see some answers still coming in. All right. In general, anything current you will not find, because the current one is the one you currently booted into and logged into. You will find control set 001 and control set 002, and you won't know which one is current control set, which is a drag, because a lot of good things in the registry, like user assist, are in the current control set. So you did this in the project, you may not remember it quite, you have to actually go find another registry key that tells you which one is the current one from the last boot up, and then look in that one. But the only ones that are actually stored are control set 001, control set 002. This current control set is a pointer to the one you're logged into while it's running. But a dead machine, which was a forensic acquisition, is just the files. It's not a running machine, and there is no information about the current control set or the current user. There's just an information about all the control sets and all the users, and you have to hunt through them and decide which one was current at the time of interest. So it's D. All right. Which one gives you 128 recently used programs? Quit at 30. All right, that's the prefetch folder. You've used it before.
I thought it was a shim. It had many more than prefetch.
Yes, prefetch has 128. Shim has much more.
Oh, I missed.
Yeah, prefetch is the old one. Yeah, very simple. All right,
How many does this shim have?
1,024. Which one do you have only on 64-bit systems? Well, I've been waiting 10 years for 128-bit systems. They keep saying they're coming, but it hasn't happened yet. Some portion of the 64-bit is actually 128-bit, like on the bus and such. What's that?
Sun Solaris had one?
Yeah. Doesn't seem to ever catch on, though.
Maybe specialized applications, I guess.
Yeah, I guess. Anyway, since this thing, WOW 6432, that's on the 64-bit system, that has to do with the virtualization.
No, it's a shim cache.
No, it's in both of them, because on a 32-bit system, you have a Shim Cache in case you've installed older versions. The version is another issue. Yeah, but this is the redirection registry key, which is used to lie to 32-bit applications so they can think they made registry changes without letting them actually follow up the 64-bit registry. All right. Let's see. Still not too late. All right, so auto-run registry keys. These things are the famous auto-start extensibility points, and it is just amazing. This is why this malware analysis is such madness. Yeah?
Is this the same thing as what you would have in a startup folder back in Windows NT?
Yes. Oh, this is all, see, the simplest way to make something start.
Is this a superset of that? Or?
Yes. Original, in
How
all
did
of
it
it.
exist in the pre?
Well, see, there was a startup folder, which is where you would logically put shortcuts, and those things would launch a startup, but that's not good enough because you might want some things to start before you log in. So then you have services, and you can set services to start at boot time or when you log in, or now you can set them to wait delayed, like 30 seconds after you log in, or to wait until you're not using the mouse and keyboard to run, like for antivirus scans and stuff. And then Microsoft, like it always does, kept inventing more and more and more ways to automatically launch things, and they didn't even document many of them, because remember, it's a closed source operating system. They do not produce documentation for everything, and almost all malware involves using undocumented Windows features. They're leaking out, probably from interior and Windows designers and also from people on the outside that are clever enough to reverse engineer it. So there are hundreds of ways to make something automatically launch when you start it, and there's no tool at all that will find them all. The best tool is the sysinternals tool that's coming up here, auto runs, and I thought it was finding them all when it put out 30, but this guy, the author in this book, says there are hundreds, and he's probably right, because that's the way Windows is. Windows is just a gigantic Frankenstein monster of the work of many companies and people all sort of sewn together, and nobody really knows what all the pieces are doing. Yeah?
You said hundreds of like third-party tools?
Hundreds of places in Windows that can automatically start things. Some of them not all documented.
So there are a lot of hooks. There are a lot of hooks.
Yes, hooks is actually a technical term for one technique. There's hooks and detours, there's a bunch of it. The malware analysis class is going to happen next semester. If you take it, we go through this in a lot more detail. So services are the most common and probably the most reasonable. The whole point of services is you have something running in the background that you're going to use, like your printer driver, like your Google updater, your Windows updater. There are things, Java wants to run an updater. There's something that launches every time you start that feels like it has to be there. And the service is actually visible and easily controlled. Yeah?
It's the same thing as a daemon in Unix?
Yes, the same as daemons and
So what's
units.
the
Yeah.
difference between auto, like the startup menu, and the services MSC or the
Services
widget?
are typically different inside. The thing about services is they don't do anything directly. They just apply. There's never a program to call on. And the startup things are often things you'll see, like things you want to launch at startup. But in principle, they all do about the same thing. Anyway, the services run in the background. Now, a lot of services run before you log in. So since they have to log, most services run as local system, which is the most powerful account on the machine, more powerful than the administrator. There are things the administrator cannot do, like dump out the password hashes. The administrator does not have enough privilege to do that. You have to elevate the system to do that. And system is the account that runs before you log in, so we can access the passwords and decide if your password is good. Then there's a thing called network system and a thing called local service that are less powerful accounts, but very few processes run as those because most people just find it convenient to give every process full privileges. All right, each service has its own subkey in each key local machine current control set services. And then you have a service name there, and here's what you got. A name for the service. Every service, by the way, has 3 names. I don't know if they're going to have that here. The image path, and different commands have to refer to the different names. Remember this? You got a description, image path, then you have how it's going to start. It can boot by the kernel loader, which is drivers. That runs in the kernel part of the operating system, which is called ring 0. That's the part that has complete access to the processor. I don't know if we've been through it in this class. It becomes a big in the malware analysis class. There is a fundamental security feature in the processor. There are 4 rings, kernels 0 through 3, but no modern operating system uses anything other than 0 and 3. The processor has about 10,000 machine language instructions, but some of those instructions are considered too dangerous for user land applications to run, so the kernel is the only part of the operating system allowed to use them. It has unrestricted access directly to the hardware. If a program you install and put on your desktop, like Microsoft Word, wants to use the printer, it is not authorized to send any electrical signals directly to the printer. It can't reach the printer. It's running in ring 3, and the commands that would send electrical signals out the pins are not available. All it can do is ask the API to please ask a kernel routine to talk to the printer for me. It's like, a president in an office that would never do any work. He asks a subordinate to ask another subordinate to please do this work, and would never get their hands dirty actually doing anything. And anyway, so this is kernel mode. This drivers are the only thing running in kernel. Then you got things that run in system, which can launch before the user logs in, and then you have other kinds of automatic. Here's ones that will automatically start when needed. Here's ones that will start only when manually started, and so on. And the user and application may launch those, and they may actually run with the user's privilege. Yeah.
Why are there hex?
Oh, hexadecimal.
Why are they numbers like that?
That's just people get used to writing things in hexadecimal because they're thinking about them bit by bit. That's all. And here's so there's drivers, file system drivers, and so on. And there's processes that depend on other processes. So this process can't run unless that one is running, and that's what's stored here, that sort of thing. Not usually that important unless you're actually going to write your own services, but a lot of malware services, and a lot of malware masquerades as innocent services. So here's what the service DIL looks like. Services are typically DILs. DILs are dynamically linked libraries. This is a decision made by Windows, which is not done typically in Linux. In Linux, you typically have a program and it's one file, and it has everything you need. But Windows, as you know, is a big, complicated, all-purpose operating system, and you typically have 10 or 20 programs running at once. So all those 10 or 20 programs, they all need access to certain common features, like the ability to open a window, the ability to read key presses and the mouse. So there's no reason to load 10 copies of the libraries that reach the keyboard and the mouse. It loads one copy, it's called a DIL, dynamically linked library, and then when you run it, the program launches its code and it says, I need this library. Is the library already there? If it is, I don't need to load it again. I'll just connect to the existing library. So the running processes are all sharing a common library, which is dangerous and unsanitary. If something bad happens to that library, it can bring them all down, but it saves RAM and it saves time. You don't have multiple copies of the library in there. It's sort of like I was saying about the imperfect virtualization of containers. You now have 2 processes that are not completely isolated as much as they would be on Linux, but when nothing bad is happening, they run faster and use less RAM. So that's how it works. Everything in Microsoft uses these DILs as much as possible, these dynamically linked libraries, and services typically run as DILs. Because a service typically doesn't do anything by itself, it just waits for requests from applications that might want it to do something. All right, the Service Control Manager is what runs this. This is a GUI, services.exe. It has a command line version, SC, so you can write scripts. They both let you set the properties of scripts. So I did an SC query on the Windows Update Service, WA user, and it tells you here it's running, it's stoppable, not pausable, has a few other codes here and so on. Yeah.
Can malware masquerade as
Yes.
updates?
Yes, and it often does. It can even inject a false DIL in instead of the real DIL. So everything that's using that DIL gets poisoned. That's the most common way malware injects.
Is that called DIL poisoning or?
Yes, DIL injection, yes.
Okay.
The most common way malware runs. All right, here's the graphical interface to the same thing. You go up in this services, you can get it in Task Manager, a bunch of places, and it shows you the name of the services and whether they've started and whether they're automatic. And what they log on as, and notice everything here is pretty much local system. There's a couple things, network service and local service, but most of these are running with highest privileges, which is probably not a good thing, but that's the way they are. And one EXE can run many services. Let me see if I can shove this thing out of the way. Come on, there we go.
To root
Yeah.
for,
Well,
Windows.
root is like administrator. Yeah.
So
there's-
what's service and system administrator? There's all these SIDs that are like.
Yeah, those are the local, those are machine accounts.
Okay.
And you got a lot more of them in domains. And it's actually a big deal because they're never supposed to log in interactively, but some attackers and malware will actually log in interactively with these system accounts. Anyway, so here you have this command task list /SVC will show you the services. And one thing that can happen is you'll notice a whole bunch of them are actually SVC hosts. The service host executable, you know, you could run Microsoft Word and have one document. You could run another instance of Microsoft Word and have another document. You could have multiple instances of the same executable running with different contents. And the service host is one of them. So these three service hosts are running just a few things at once. This one running DHCP, so you can connect to a network. These are running group policy. This one's running a whole bunch of things. So there's a lot of services, but they're all running under one executable, and they're batched together. Anyway, that's the way it is. Yeah.
I'm on like the email list for the Windows 10 Insider, and they're going to get rid of service host or something like that.
Are they? Oh boy, well that'll be a big change. That'd be interesting, yeah. They do this a lot. Microsoft does gradually get tired of things and throw them away and replace them with new, more complicated ones, so you have to sort of stay on board, yeah.
These are separate instances of the same executable?
Yes, so you run the
Running on
executable.
different threads?
Yeah, the executable is like a shell, and it runs certain services. And they batch them together to make them compatible. So these all run with that executable, and those all run with that executable, and so on. That's how they do it. All right, so our run keys are the first thing you look at when you're thinking about malware starting. This is the most common place people talk about. Services is probably the first place you should look, but runs they talk about a lot. There are four of them. There's a run key, a run once key, and then there's over here a run once key and another run once key. The run once keys, if you put a program in there, it will run once the next time the event happens that triggers it, which is usually a logon or a startup. And the run key will trigger every time you start up. That's the difference. And so if you can change any of those values, you can make malware automatically run. All right, there's also something called active setup. These are subkeys with a thing called a stub path that will run to it. The stub path goes to EXEs, which will run on startup. And this is why, you know, if it was Unix, I think, because Unix is ultimately all answerable to Linus Torvalds, and he's real stern about it, he wouldn't let you make 100 different ways to make something launch at startup. I would think he would say, this is garbage, you should have one thing, and they do have these ways to make things launch at startup, and everybody has to like fit in this structure. But as you can see, none of that ever happened here. Just every little team invented their own way of doing it, and as long as you didn't stop anybody else's work, everyone just proceeds. Then there's AppInit DILs. These are pretty crazy. Suppose you have a library that, like you're using a funny kind of mouse, and every application is going to need to use that mouse and get to this special library to use it. So you want every program to connect to this DIL. That's what this is. There's this thing called AppInit DILs here, and you can list them here, and every program that launches that uses user32 will also launch all the DILs in the AppInit DILs registry key. User32 is launched by almost every program a human would use because it's the thing that draws windows. You can't open a window and let the mouse click on something without using user32.dil. And this, so you can put things here, and if you do, it'll end up linked, if you put malware in there, it'll be linked to every program you launch. Every time you launch any program, it'll be launching the malware too. And you'll end up with a bunch of them running in memory. This one is good, clean fun, the LSA secrets. The local security authority is one of the many very disturbing things. And this, again, comes from convenience. So back in the days of Windows XP and Windows 2000, you might have a Windows machine and you connect to like an FTP file share and put in a name and password. And then you go doing your work and an hour later you connect to it again. And Windows wouldn't want to make you type in the name and password again, so it would save it somewhere. They called it the local security authority. So there's a second place to store passwords. The normal login passwords are in the SAM file, but there's a separate store here called the LSA, which is a little bit like Apple's keychain. And the original versions of it actually stored things in plain text. You could recover them here. And one of the awesome things about Windows XP was you could get the local administrator password that last logged in plain text from this file. It was amazing. It totally subverted the security model. They've improved it a little bit since then. Yeah.
Just a quick aside, is this the same thing that's used by the LSAS specialist? Or
No, that's totally different.
Oh, it's
Yeah,
totally
that's totally different.
Is that authentication?
It's similar, yeah. Yeah. So, but that's the point. The point of this thing is there's a couple of packages here, and again, see, you can now have special authentication packages. Like if you're going to put in a thumbprint reader on a USB, now everything that has you logging in is going to have to be able to read that thumbprint reader. So you're going to have programs that have to launch and tie into authentication. That's the point of this. But again, it can be malware. And then there's the BHOs. This is probably the most common kind of malware people get mad about. Your browser goes to a different home page, your search engine is hijacked, you try to download things and they won't download, and you get really frustrated. This happens to everybody, it happens to Macs. These are called browser helper objects. There's a euphemism if I ever heard one. But that's how you have the Yahoo toolbar, the Google toolbar, and in principle, maybe 10 years ago, these things were actually some use and somebody wanted them. Now, as far as I can tell, they're all just malware. But anyway, here they are. You can enumerate the browser helper objects are stored here. Software Microsoft Windows current version, Explorer, browser helper objects. And you have a whole bunch of class IDs there. They're just long random looking numbers and you can enumerate them. All right, that's where they are. And then you have shell extensions. And what these are, you remember in the projects, I'd say right click and point to 7-zip and unzip a file. Because after you install 7-zip, something's in the right click menu. That goes here. That's a shell extension, which ties to the shell, which is the Windows desktop. That's Explorer.exe is the executable that draws the desktop, and these are the registry keys that customize the desktop. Yeah?
Windows NT, as told by my cousin, was designed after requirements from the DoD, actually, and also modeled after Unix. So this is kind of like architecture, file system layout.
That's true. Anyway, and so that's what's happening here, and you'll find them here. So here's my machine. It has 7-zip. So down here in these shell extensions, there's 7-zip options, and that's why you see a 7-zip when you right-click. All right. The Winlogon Shell. This one is pretty good fun. There was a real old exploit to get into Windows NT where you replace the process that drew the desktop, and you can do it in a modern version of Windows. This is the shell. See, in Unix, in Linux, when you start, it'll decide what shell you want to use. You have a command prompt. You might want the corn shell or the bash shell or the C shell. Windows has an option, but there's really only one you want to use, which is Explorer.exe that draws the desktop. Now, there's a condition under which you might not want to. For example, Vista had a mode where if you didn't recognize your product key for 30 days, it would go to a mode called Reduced Functionality Mode, where you didn't get the Start button anymore. All you got was Internet Explorer. And you can also have kiosk machines, like in department stores, where it's just supposed to be used to like present a map or something, and you know people aren't supposed to be browsing the web and playing games on it. So you can change this to launch something else, like a web browser. But here's what it is. This is where you specify the shell. You can set it to any executable. If you do, that's what will launch when the machine starts up and someone logs in, not the Explorer that draws the desktop. So if you were malicious and you wanted to launch malware, you could make something that runs your malware and then calls Explorer. So people won't notice anything wrong and you get your malware running. And then there's Userinit. These load group policy scripts. More auto runs in the Explorer shell, and you can add extra things here. These are just more things that happen after someone logs in to prepare the machine for use. So if you look at all the auto runs, you go through these keys and find lists, you have a bunch of things, and it's not obvious which ones are malicious. So one thing you can do is eyeball it. See, you can look for things like misspelled words, bad English, things that are obviously in the wrong path, like things in the root of C or somewhere stupid like that. So try this one. You got eye clickers. See if you can determine which one of the next things is malicious. See if I can get my thing to work. There. All right, which one of those is a malicious object? I'll wait a while. I think there's at least 13 students. I don't know if I'm going to grade it. I might grade it. Well, this won't be on the quiz.
No, I mean.
I think I'll grade it though.
I clicked it. Sorry.
Because there is one possible way to get this right if people actually read the book. That's probably the only way. Anyway, I'll quit at 55 here, and we'll see how people did. All right. And the right answer, which I didn't get, is B. Least popular. Now, and the point is, this is actually a Hewlett-Packard thing. It's a real thing. Haven't used a printer driver. This is RIP. RIP is a real protocol, but it's not called IP RIP 32. It's just IP RIP. This is actually a malicious protocol looking like Windows. This thing has monitored spelled wrong, and that's the way it really is for the people that wrote it. And this thing is Synergy, and it's fine. That's what it really is. So B is the malicious one.
Which one got the most answers?
Oh, that got the least answers. I know that.
Evenly distributed?
No, not at all.
I put D.
A and C. A and C are the most popular answers.
Never mind.
Yeah. Right.
But
And
B is the correct.
B is the correct answer. But it's essentially impossible to tell. The only way to tell is if you have enormous experience and you know like the top 1,000 things.
I looked
yeah.
at listens, and it's also misspelled.
Hmm?
I looked at listen, it's misspelled.
Yeah, yeah.
And then I looked at
Yeah.
monitor, and it's
The problem is
misspelled.
real components, even Windows components, can be misspelled too. Yeah. Anyway, so here's a better procedure than just trying to see it look nasty. First, things signed by trusted publishers, you can probably exclude them because they're real commercial products. Things created outside the time window, if you have a time window, that's one way to get rid of them. Then look at the paths. Attackers tend to use paths that can write to. See, the problem is a normal real product installer, if you're installing something like Microsoft Word, it will create some folders and it will put things in those folders. But if you're a malware writer, you aren't probably really expecting to get enough rights to create folders. You're trying to hide, so you're trying to put it in a folder that's already there. So you will pick a folder that is always there, not a folder that's custom to that application. Put it in someplace like a temp folder or something. So referring to those folders that are not tied to one app is a clue that this stuff is malware. And instead of using deeply nested subdirectories, which is where you're supposed to put things these days, like user profile, app init, software, long, complicated paths is where you look where your Word templates and your Word preferences are going. They're about 10 levels deep in a thing labeled Microsoft Word. Then you can try the remaining binaries and calculate their MD5 hash and look at them at virus total to see if they're known bad or bit9 to see if they're known good. And the remaining unknowns, you can just compare them to the system image that installed this, because everybody deploys images. And you'll see if it's in the image, I guess it's okay. If it's not in the image, then maybe not. That means it got added after this image was deployed. Yeah.
That's what you recommended for the CCDC, right?
No, the
Not
CCDC.
this whole procedure, but like the
Yeah,
other-
it's not a bad idea. Yeah, yeah. But I mean, I think like I said, the CCDC, this is a big issue. There are all these complicated security measures, but in the cyber defense competition, they say, and all the experts, Mandia too, in this book, he says, don't get fancy. Tell me, have you really changed all the default passwords and put on all the updates? Don't even talk to me on anything complicated until you've done that. And so that's the first thing. Yeah. Anyway, all right, and like there's tools. Sysinternals auto run from is the tool that finds as many of these things as any other tool I know of can find. It finds about 30 of them, not all of them, but it's most likely to find what's running on your machine, and Mandia Redline finds some of them, as you saw in the project. Well, we will see when you do that one. Anyway, signed malware. Used to be a general rule that you could trust anything signed, but about 4 years ago, some Chinese company, some bad guys somehow got their code signing key, either by bribing them or hacking in or something, and now that's happened several times. So now there is a considerable amount of malware that is signed. It's not all the malware, or it's not most of the malware, but it's enough that just because something is signed does not mean you can trust it anymore. There are stolen code signing keys. All right, a few eye clickers about that stuff. And I think I was correct not to try to cover any more than the registry today. It's enough. Get this thing slightly visible. All right. So, got another section after this. All right, which one of these is command line? Well, we'll take a break after this one. I'll quit at 30. All right, and that's SC, of course.
Oh, what is that?
SC is
I changed my answer.
SC is how you control services from command line. SC, start and stop, and so on. All
I
right,
thought it was services.
services is the GUI.
Oh, that's Linux, actually.
Yeah, in Linux it's services.
Sorry.
In Linux it's services, and in Windows services exist, but it's the GUI.
Yeah.
All right, so which one of these will cause malware to launch every time you launch an app that uses Windows? Which is cute and an alternative to having it start on system startup. Now in Linux, they have these things called run levels, and there's about 7 of them, and everybody has to use them, instead of having 100 random things invented by everybody like this. All right. As far as I know, if there's a Linux expert out there, you can tell me there are actually 100 ways to do this in Linux, but I don't think so. Anyway, those are app init dills. Every time an app starts, it launches those dills too. All right. So, the Yahoo toolbar, what is that thing? Yahoo isn't dead yet, are they? They've been, for the last 10 years, Yahoo has been on the edge of death, and it never happened. Somehow they always manage to swirl around the drain another time. Anyway.
It's like Dick Cheney. They
Yeah,
get
yeah.
you hard every time.
Yeah. They've been doing everything wrong for 20 years, but they never die. Anyway, so, all right, browser helper objects. That's what they are. Helper ought to come in quotes. Anyway.
I don't know why is it not, what shell extensions again?
After this, I'll tell you. But that's fine. So which item is normally set to explorer.exe?
Why do you have 5 options?
Why not? Because there's 5 buttons.
Yeah, that makes it hard to.
Oh, yeah. That's exactly why, to make it hard. That's my job. All right. So this is Winlogon Shell. That's the shell. The shell that you launch is explorer.exe. Now, and the answer to your question is it's shell extensions are the things that add to the right-click menu. And that's what.
That's right.
Yeah. But the Winlogon Shell is what launches when you log in. Anyway,
What's Winlogon Userinit? Is that
Um,
just a variant of?
Userinit.
I'm not sure either.
Userinit is another kind of things that launch when you log in, and I forget what makes it different. All right, so let's take a break till 7:10, and then we've got another session of this to go through. It is just amazing as you study Windows how messed up it is, and yet it's very popular because it's the answer for every problem. It's all purpose. Whatever you're doing, Windows has at least 10 ways to do it.
It's a billion line of code.
This is 12C, I think, something like that.